Have you ever just watched a newborn and wondered, how does that tiny person who can barely control their own hands eventually turn into a teenager who can debate philosophy? Well, today we're diving into the secret architecture of a child's mind. We're going to look at how it's built from the ground up, turning the simplest sensations into the most complex, abstract thoughts. I mean, really think about it. The journey from a purely physical, reflexive little being to a thinking, reasoning person. It seems almost magical, doesn't it? But, as we're about to see, it's not magic at all. It's actually a structured, predictable, and frankly, a brilliant process.
Okay, so to really understand this journey, we first have to wrap our heads around a pretty fascinating paradox that sits right at the heart of how we learn.
Right. So we all assume that learning is about accumulation, adding facts, adding skills, adding experiences. But this model suggests something kind of radical, that the real cognitive leaps happen not by adding, but by subtracting. Growth is actually powered by strategically quieting our most primitive impulses. This whole idea actually builds on the foundational work of Piaget. He talked about two main ways we interact with the world. First, you've got assimilation. That's basically when we use a skill we already have on something new. Think about a baby's instinct to put any new toy in its mouth. But then you have accommodation, and that's when we have to change our behavior, create a whole new skill to deal with something brand new.
And this is where it gets really interesting, because this shows the key difference. Look at the examples. Assimilation just follows the old program. See an object, put it in the mouth. Easy. But accommodation, that requires something totally new. The baby has to inhibit that impulse to mouth the block so it can do something more advanced, like just looking at it. That tiny little act of self-restraint, that's the spark of higher thinking.
So, if inhibition is the spark, then what's the engine it's powering? Let's take a closer look. Now, when we say inhibition, it's not about suppression in some negative way. In this model, inhibition is a creative act. It's the mind strategically quieting the noise of those primitive, action-based impulses to clear a space for more complex thoughts and feelings to actually show up. So, according to this model, our development follows this really clear path through 3 states of awareness. We start out in a state of willing, which is all about pure, physical, impulse-driven action. From there, we move into feeling, where we can be present and oriented in an experience. And finally, we arrive at thinking, the world of abstract ideas. You could almost say the journey is from doing to being to knowing. And what's so fascinating here is the relationship between these states. Get this. For thinking awareness to be fully expressed, our willing awareness, that raw impulse for immediate physical action, it has to be significantly inhibited. It makes sense, right? You can't be deep in abstract thought while your body is just consumed by the impulse to run around. One has to get quiet for the other one to speak up. I absolutely love this metaphor from the source material. Thinking isn't built by adding more clay to a lump. It emerges as the sculptor. The developmental process itself chips away at the raw stone of pure impulse to reveal the sophisticated form of cognition that was kind of hidden inside all along. And you can really see that idea right here. The image on the left, that represents that raw, dominant, willing awareness. And then as you move to the right, you can see it being inhibited, sculpted, refined, allowing that more nuanced form of thinking to take shape. It's a beautiful way to picture it. Okay, so the process is like sculpting. But what's the blueprint? I mean, how does the mind know what shape to create? Well, let's look at how this whole process builds up from our very first sensations. Here it is. This is the blueprint, this beautiful 4-quadrant map. This model suggests that our entire cognitive architecture is built on 4 foundational physical senses. And we're not talking about sight or hearing. We're talking about the ones that tell us about our own bodies: touch, life, movement, and balance. Each one of these gives rise to a specific perception of the world, which in turn becomes the absolute bedrock for a higher cognitive skill. So here are those 4 pathways all laid out. Just look at the top one for a second. The physical sense of touch is what first gives a child a perception of a boundary, where I end and the world begins. This super basic perception then forms the foundation for the cognitive ability to see correspondences between different things. It's a direct line from the body to the brain. Let's walk through one really concrete example to make this stick. Imagine a toddler teetering on a curb. She's feeling the raw sense of balance. Through that experience, she builds a perception of difference, what it feels like to be stable versus what it feels like to be unstable. Now, here's the crucial part. That physical experience is the direct neurological foundation for the later cognitive skill of comparing two abstract ideas in a classroom. It's the same mental muscle. And this isn't just a theory. This entire blueprint unfolds on a predictable timeline. You can actually map it directly onto a child's development right through their school years. In those first 6 years, the main job is all about building that foundational layer, connecting those raw physical senses with their corresponding perceptions. The body is literally laying the essential groundwork for everything that's going to come next. Then, when you get to elementary and middle school, development follows this amazing repeating 4-year cycle. Look at cycle 1. In first grade, the focus is on boundary and correspondence. That's the skill that grew from the sense of touch. Grade 2 focuses on wholeness and analysis, and so on. But now, check out cycle 2, starting in grade 5. The pattern repeats, but at a much higher level of abstraction. So even though analysis is the focus in both grade 2 and grade 6, a 6th grader is revisiting that same core function with way more complexity. The mind isn't just learning new stuff, it's spiraling up, deepening its understanding over time. So, we've got this complex architecture, this predictable timeline, this engine of inhibition, but what's the one activity that integrates all of it and actually makes it happen?
Well, the answer, according to our source material, is both simple and incredibly profound. It's play. And not play as some break from learning, but as the very work of learning itself.
Just think about it for a second. Play is where all these concepts come together. It's the training ground where a child practices inhibiting their immediate impulses to achieve a goal. It's where the physical work of balancing on a log literally forges the neural pathways they'll need for the mental work of comparing ideas later on. Play is the engine room of development. This right here is the key takeaway. It's a direct, unbroken line. The physical, sensory-rich work of childhood play is the essential, non-negotiable prerequisite for the abstract cognitive work of the classroom. It all comes down to one fundamental activity: building this entire magnificent system from the ground up. Which, of course, brings us to our final and maybe most critical question. If this model is right, if the entire complex architecture of the mind is built through sensory experience, inhibition, and most of all, through the one fundamental work of childhood, which is play, are we creating the right environment for our children's minds to truly grow? It's definitely something we're thinking about. Thanks for tuning in to this explainer.